Hey everybody, my name is Jacob Owens, and today I'll be presenting my research on the effects of non-forested habitat on southeastern American kestrel nest success, and we tackle this specifically by way of a multi-scale habitat selection study. So first I'd like to delve into a little bit of biology on the American kestrel. The American kestrel is the smallest falcon native to North America. It's roughly the size of a mourning dove, and that's a little bit smaller than a football if you don't know what that scale is. So the species is in a range-wide decline according to both Breeding Bird Survey and Christmas bird count data trends. This here shows the Breeding Bird Survey data trends from 1967 to just about now, and it exhibits about a 50% decline in the species as a whole. However, in Florida, the Florida Fish and Wildlife Commission says that within their state, there's been an 82% decline in the southeastern American kestrel specifically. And this bird right here is a southeastern American kestrel, and is the smallest and non-migratory subspecies of American kestrel that can be found south of the fall line within Georgia. And the Georgia Department of Natural Resources has this subspecies listed as a species of concern within their 2022 State Wildlife Action Plan. A little bit about the nesting ecology of the American kestrel. The American kestrel nesting season is between May and June, while the southeastern American kestrel nesting season is between May and July, which is just a little bit longer. And they typically have 4 to 5 eggs per nest, and if there is a nest failure, the hen will readily re-nest in that situation. Like most raptors, the southeastern American kestrel exhibits asynchronous hatching. And asynchronous hatching is when the incubation begins after the first egg is laid, as opposed to synchronous hatching, where all eggs are laid and then incubation begins. And double brooding has been reported in southern portions of the southeastern American kestrel's range, specifically in northern Florida near Eglin Air Force Base. However, this year during the 2023 nesting season, we saw the first instances of double brooding within our study area. And some reasons for decline in the southeastern American kestrel are changes in timber harvest regimes that lead to more intensive forest management, which then in turn leads to shorter rotation ages. And with trees not being able to mature, they can't form natural cavities. And historically, red-cockaded woodpeckers would excavate cavities into live trees. Those trees would then die, and then northern flickers, another type of woodpecker, would come in and expand those cavities. But as many of you know, the red-cockaded woodpecker is on the endangered species list now, and northern flickers are not able to keep up with the workload that the red-cockaded woodpeckers once maintained. All of these factors, coupled with the fact that early successional habitat suitable for kestrel foraging has declined throughout the southeast, and some of their prey species that they focus on are grasshoppers, small mice, lizards, and snakes. Due to the unavailability of natural cavities, the Georgia Department of Natural Resources started a nest box program in 2013 in order to increase the population of kestrel within the state. And nest box programs have been successful at various different species such as wood duck, eastern bluebird, and American kestrel. One instance of this is in Michigan in cherry orchards in a Michigan State study. It was shown that in cherry orchards, artificial nest boxes have increased nest success over those natural cavities in areas surrounding them. This has been reflected in our subspecies in that same Eglin Air Force Base area, that in the southeastern American kestrel, that this trend is also upheld. And currently, as we stand, there is no population evaluation for kestrels within the state of Georgia. However, this nest box program over time will allow us to form a population estimate as we get more data with the years this study goes on. So the way we chose to tackle this was a multi-scale habitat analysis. And the habitat analyses are used for various taxa such as mammals, fish, and birds. However, it's important to understand that there is currently no accepted home range shape or size for the American kestrel or any of its subspecies. So any home range estimates made in this presentation are based off of kestrel nesting density, which varies between 2 and 4 nesting pairs per square kilometer. And if you express a square kilometer as a circle, you get a radius of about 500 meters. So our 3 scales that we use within our study are a local scale of 250 meters, a home range scale of 500 meters, and a landscape scale of 1,000 meters. And the reason why we use a 500 and 1,000 meter scale is that Miller et al. Has shown that grass cover significantly affects kestrel nest success in Florida at these 2 scales. So the overall goal for our project is to improve nest box placement for managers throughout the Southeast in order to bolster the populations of Southeastern American kestrel throughout our region. And our objectives were to determine if the proportion of non-forested habitat surrounding artificial nest boxes affects nest success in Southeastern American kestrel. And if that does, we need to assess which habitat scale or scales affect nest success, if any. So when you're looking at this figure, it's important to note that the American kestrel's distribution is all of North America. However, the shaded region indicates the Southeastern American kestrel's distribution, while the red dot is our study area. Our study area is about 40 miles wide between Columbus and Butler, Georgia, and it is all within the Sandhills ecoregion of Georgia. The dominant land use types for this area are agricultural, energy production in the form of solar farms, as well as conservation lands. And there are 114 nest boxes that have been erected within both public and private land in the study area. The dominant overstory tree species is longleaf pine with turkey oak mixed in, and it is impossible to know what the fire regime is in many of these areas within our study area because of the complexities of working with public and private land, with them having varying management objectives. So the methods that we used in our study were that we visited boxes on a bi-weekly basis, if not sooner than that. And we used a peeper camera, as shown here, in order to assess chick development. And the reason why this is important is once chicks are 14 days old, they can be sexed. And we were able to determine age using a visual estimation guide. And once we could sex the kestrels, we could band the kestrels. And in our study, a kestrel that was banded was found to have fled from the nest. And once we finished all of our field work, we used ArcGIS Pro to delineate different habitats. In our study, we had 2 habitats in mind. We had forested habitat and non-forested habitat. So non-forested habitat has less than 50% canopy cover, while forested habitat has greater than 50% canopy cover. I included this figure here in order to show you all what 25, 50, and 75% proportions of non-forested habitat looks like on a local scale. So at this point, I think it's important to redefine what our habitat scales were. And that was a 250 meter local scale, a 500 meter home range scale, and a 1,000 meter landscape scale. We also had 3 nest success classes that we used within this study. We had successful nests where at least 1 chick fledged. We had attempted nests where there was eggs laid, however no chicks fledged. And we had no use boxes where there was no use within the 2023 nesting season. And we used a 2-factor ANOVA with an alpha value of 0.05 in order to statistically analyze our results. And some preliminary results that we got were that all nest boxes were visited on the predetermined schedule, if not earlier, as I mentioned earlier. And there were 40 successful nest boxes, 23 attempted boxes, and 51 unused boxes within our study. There were a total of 146 chicks that were banded during this nesting period, which is the largest number of nestlings that have been recorded in one nesting season. And for the last 6 years, there's been about a 20% increase in nestlings per season, which would indicate that next year there'll be about 175 chicks in the 2024 nesting season. This program also displayed 35% of boxes with successful nests, which is also a record for the nesting program. So out of the 145 nestlings that were within our study, we only found that 2 of them had died within the box before they fledged, giving us a 98.6 fledging survival rate. And there was a mean of 3.45 nestlings per clutch in our successful boxes, as well as nest productivity being 2.3 nestlings. And the way that you calculate nest productivity is by taking the total number of nestlings and dividing by the number of successful and attempted boxes. I'd like to point out that our nestlings per clutch and nest productivity were both lower than all other literature out there. However, I believe this can be accounted for by our increased sample size than other sites, as well as the southeastern American kestrel being the most imperiled of all the subspecies of American kestrel. So when we're analyzing our results, we look at our two-way ANOVA table. An ANOVA stands for analysis of variance, and we have 2 factors. So let's identify what those are. We have nest outcome and habitat scale, with our response variable being the proportion of non-forested habitat around those habitats, within those habitat scales, excuse me. And because this is a two-way ANOVA, there's also an interaction factor. However, we found no significant difference there. When we ran the initial test, we found that nest outcome had the only significant p-value of 0.0018, which is well below the indicated 0.05 critical threshold. So now that we know that there is a difference within our data, we have to find where that difference lies. So in order to do this, we run a post hoc mean separations test in order to parse out the data and find where that difference is. We used a Fisher's least significant difference test in order to do this, and we found one set of significantly different results. That was at a local scale. We found that successful and attempted boxes had a significant difference. And what that means to me as a kestrel manager is that kestrels nesting opportunistically in areas with lower proportions of non-forested habitat are not having the same nest success as kestrels nesting in areas with higher proportions of that non-forested habitat. There is also a general trend within each of the habitat scales, and that's within the successful bars. And each successful category of nest always had the highest proportion of non-forested habitat on average. So what does this mean for kestrel management? Previous kestrel managers were under the impression that larger scales of suitable habitat were needed for kestrel nest success. However, our research suggests that in sandhill habitats at least, we need to focus on a more local scale when managing for nest success. So current nest boxes only need to be intensively managed at that local scale rather than a more landscape scale approach. And new nest boxes can be placed in areas with less area of suitable habitat at larger scales if there is that high quality habitat at more local scales. So we can expand our nest box program to areas that have been previously foregone from thought due to habitat limitations. At this point, I would like to acknowledge that this study only analyzes 1 year's worth of data, and further studies should retroactively and into the future look at different years to see if this trend is upheld. And all previous habitat studies have not included a local scale within their habitat analyses. However, we found that this is where a significant difference lied. But since we don't know what the home range size or shape is for the southeastern American kestrel or the American kestrel at large, how do we know that 250 meters is truly a local scale? It could be a home range or even a landscape scale, and until that study is done, we have no way of knowing. So we recommend that further research be conducted to assess what the home range size and shape is for our subspecies and the species at large. So our study did not examine the impact of habitat connectivity on kestrel nest success. And if you don't know what habitat connectivity is, the figure on the top here shows a poor example of habitat connectivity with the non-forested areas in mind, and the figure on the bottom shows a much more connected habitat. So the reason why this is important is previous studies have shown the importance of non-forested habitat connectivity in agricultural landscapes. However, none have been done on natural landscapes. So in the future, we recommend that further study is conducted to see if this trend is upheld within natural landscapes on our subspecies. And when we used our analysis through ArcGIS Pro, we analyzed a lot of satellite imagery. And one of the drawbacks of using satellite imagery, especially for when this time was taken, is that we had imagery from winter of 2022. And due to the nature of trees, such as deciduous trees, not having their leaves during this time, we could be skewing data to have higher proportions of non-forested habitat, even though this is a primarily evergreen system, as you can see here. On top of this, by only using satellite imagery, we cannot assess specific habitat qualities such as grass cover or understory species composition that would help us figure out what is driving kestrel nest success at a more direct level. So in the future, we recommend that future studies have random sampling procedures to create a ground truthing factor that we can apply to our satellite imagery and create more accurate data into the future. We also have some applications in orchard management. As I mentioned earlier, the Michigan State study was done in cherry orchards, and in that study, they found that kestrels actively targeted pests in the orchard systems while actively avoiding the beneficial insects within those systems. So I believe that for the sake of kestrels and expanding their nest box habitats, as well as economically benefiting the orchard systems, there should be further study conducted in order to see if this is applicable within our region in the peach orchards that we have in Middle Georgia. And when we used a two-factor ANOVA, we understood that there were some limitations that came along with this. One of these limitations being that if you have a large enough sample size, you're going to find a significant difference. The other limitation being that you can only analyze one habitat model at a time. So in the future, we recommend that researchers use an Akaiki's information criterion test in order to test several habitat models at once to find which habitat model is driving kestrel nest success. And it is important to note that previous studies have done this on larger habitat scales on our subspecies. However, they have not included a local scale within their study, which may provide insight into the future for kestrel nest success. I would like to acknowledge the Georgia Department of Natural Resources Wildlife Conservation section for their willingness to let me conduct this research during my internship. I'd like to thank Dr. Joyce Klaus for her help with statistical analysis, and Nathan Klaus for his mentorship during my internship, and Drs. Jason Scott and Vanessa Lane for their help in making this project what it is throughout senior project, and specifically Dr. Scott for being my mentoring advisor and helping me through every step of this process. I'd also like to thank all my literature reviewers, such as Dalton Hemmings, Michael Stewart, Emily Purvis, and Josh Clements, who really helped me take this paper to the next level. And not mentioned here, I'd like to thank Hal Massey for providing me with many of these photos that I used during the presentation. And I'd also like to add that Dr. Scott, Nathan Klaus, and I will be submitting our research to the Journal of Raptor Research after one more round of revisions. And with that, I'll take any questions you guys may have.
Questions for Jacob? can you please go back to the image that you had, the circular images for the habitats at the different scales? It was way in that one right there.
Did I miss it?
Yep, you went by it.
No, it's this one, right?
No. The actual satellite images that had the 250. There
Oh.
we go. So in the middle, you have 50% non-forested habitat, but it also looks like there's about 20% of that circle that is just not habitat. And also in the 25% non-forested habitat, you have a freeway, in which case the pavement itself is not a habitat. So when you were trying to figure out your proportions of forested and non-forested habitats, did you actually pull the unavailable habitats out of your home ranges to kind of normalize what really was available habitat?
So in the case of water, like shown here or here, I did not take those out just because they could use that as a resource within their habitat. However, with these freeways, I can say that as visiting these sites multiple times, I've seen kestrels using these freeways. Even if they have to cross the road, they can still forage for insects in that area without much problem. And many of the nest boxes along this road specifically are positioned directly next to the highway. Sam?
Yeah, so you, maybe you went over this and I didn't catch it, but you talked about forested habitat versus non-forested habitat. Did y'all look at forested habitats that have really low basal areas? And then how would you classify that then?
So any forested habitat with less than 50% canopy cover was classified as non-forested by our definition. That answer your question?
Yes, I may skip it.
Okay.
So you have 3 different scales. You got 250, 500, and 1,000.
Yep.
Has there been any? I realize that the home ranges aren't known. Given that, have there been any telemetry studies that actually examined, like distance from a nest that they travel from for foraging outside of the context of a home range?
So the only study that I'm aware of is on natal dispersal.
Okay.
In chicks, and it only shows that they go a maximum of 2 kilometers away from the nest, and that is in very odd circumstances. They usually stay within 1 kilometer of the nest.
Wow. Was there any sex differences, like with RCWs?
Females tend to disperse further than males, and males will take over their, I guess, father's box when they die. It's very interesting.
It's very similar to RCW. That is very fascinating. I wonder if that's like a trend for coastal plain birds. I don't know.
Especially in this ecosystem. They share the same ecosystem.
Right. It's interesting.
Dr. Scott.
In your introduction, you had talked about how with the increase in artificial nest boxes, how that would offer the opportunity to provide a population estimate. Can you elaborate on how you think that would actually work?
So since we have no level of kestrel within our state, we have no understanding of how many there are. If we can document the number of kestrels being introduced into the population each year, and if further studies are conducted to see what the survival rates are, eventually we can create that estimate and see how many kestrels approximately are on our landscape.
Okay, I'm just not seeing the connection on how that would account for all the other area within the range, because it covered quite a bit of our state.
Yeah, it does.
And maybe even that being a density estimate of the local area, just in your study area. It would have to be, to me, I would think it would have to be an independent sample of some kind.
Okay.
I just wasn't sure we could get to a population estimate. So you might adjust the language on that.
Okay.
You said something interesting. Well, a lot of things interesting, but one thing interesting that you said was that the productivity you noticed is lower with the southeastern kestrel than it is for the migratory kestrel.
Sparberry.
So I'm assuming that means the clutch sizes are smaller.
I would assume on average.
Okay. I'm hypothesizing widely here. But do you think it's perhaps that the migratory species, because they are subjected to more adult mortality during migration, that they have to have higher productivity, and so the lower productivity that's being seen in the resident population isn't necessarily a bad thing, it's just a result of life history differences?
I believe that is something that could be accounted for.
Mhm.
However, well, actually not however, I think that is the correct analysis of that data.
So I mean, the caution that I have, because it seemed like you were trying to say, oh, and this is a concern because
I don't think it's it may have came off like I thought it was a concern. I was just noting that it existed and
Okay.
some reasons that I thought could be accounted for. I hadn't previously thought about the migratory history of the other subspecies.
Mhm.